In this video, we are going to discuss about the multi-stage amplifiers. On the completion of this topic, the students will be able to demonstrate the knowledge in the four things. That is, one is single stage bipolar junction transistors and the metal oxide semiconductor field effect transistor amplifiers. And next one is feedback amplifiers and oscillators. Next, they can demonstrate the knowledge in the power amplifiers. And the fourth one is they can use the biasing of the integrated circuits and active loads. And the multi-stage amplifiers, so here we are using we need an amplifier for amplifying. We need more than one amplifier to amplify the signals. So if you are amplifying an signal in a proper way, it contains some of the weak sources that can be amplified with the along with the noises. So in practice, we need some extra amplifiers for amplifying the signal from the very weak source. That is, we are taking a if you are taking a microphone or some other devices, if it is having a low operational level, that is, if it is considering containing a very low operation, means we are using some other extra amplifier to high up the weak source, and so that this can be used as another transducer, such as we are using it as a loudspeaker, or we are calling it as a loudspeaker. So this can be achieved by cascading the number of amplifier stages. So if more than one amplifier is cascaded, then we call it as multi-stage amplifiers. So why we go for this need for cascading, means for this faithful amplification amplifiers, so we should have a desired voltage gain, current gain, and also it should match the input impedance. So if this input impedance is matched with the source and the output impedance with the load, we will be getting the faithful amplification amplifier. So these desirable things should be satisfied to obtain the faithful operational amplifier. And next one is, many times these primary requirements cannot be achieved in the single stage amplifier due to the limitations in this FET or the transistors. Since these parameters are having single limitations, so we are going for the next primary requirements. That is, many times we go for the single stage amplifier, but it does not limit, it has some limitations. So due to that, we are going for the multi-stage amplifier. So in such situations, we are using more than one amplifier stages, that we can cascading such that this input and output stages will be providing the input matching requirements, which is used for some amplification, and the remaining stages we are using for the most of the amplification. And here, when this amplification of the single stage amplifier is not sufficient, or if this input or the output impedance is not correct in the magnitude for the particular application, that is, two or more amplifier stages are connected in cascade, so such amplifier with this two or more stages, we call it as multi-stage amplifier. So here we can see the two-stage cascader amplifier. So we are using the stage 1, stage 2. So input or the output impedance, if it is not in a correct amplitude, means we will be going for this cascading. So in this cascading, the first input is given to the stage 1, and the output of the first stage is given to the input of the second stage, and the second output we are giving as an output. And also here we are using the load resistance. And here you can find out that there is VI1 is the input of the first stage, and VO2 is the output of the second stage. So VO2 by VI1 is this the overall of the voltage gain of this two-stage amplifier. So we know that is voltage gain is nothing but VO2 divided by VI1. So we write this equation as VO2 divided by VI2 into VI2 divided by VI1. So finally we can write this equation as AV is equal to AV2 into AV1. And in the case of we are taking the n-stage cascader amplifier, due to some limitations in this multi-stage amplifier, if we can go for the n-stage cascader amplifier, so you can see that is VI1 output of the first output of the first voltage, that is VON, is connected to the VI2. So from this it goes on n stages. So to find out the resultant voltage gain of this multi-stage amplifier, there is nothing but the product of the voltage gains of the various stages. So you can write this equation as, that is AV is equal to AV1, AV2 up to AVN. So this N is equal to is nothing but 10 log P2 by P1. In decibels, if you are writing this gain as, in many situations, if you are finding out it is not convenient to compare these two powers on this logarithmic table rather than this linear scale, so this unit of the logarithmic scale is called as the decibel, and also the number of decibels by which this power exceeds the power P2 is defined as N is equal to 10 log P2 P1. And here this decibel is nothing but it denotes the power ratio. So the negative values of the numbers, that is of dB means that is power P2 is less than the reference power P1, and the positive power is of this dB means the positive power P2 is greater than the reference power P1. So in here P1 may represent input power and P2 may represent the output power. In the both the cases we can write this equation as n is equal to 10 log 10 V naught square divided by R naught divided by Vi square divided by Ri. And here we know that is Ri and R naught are the input and the output impedances of the amplifier. If this input and output impedances of the amplifiers are not equal, we can say this equation as Ri is equal to R naught equal to R. From that P1 is nothing but Vi square divided by Ri, and P2 is equal to V naught square divided by R naught. So from this equation we are writing that is n is equal to 10 log 10 V naught square divided by Vi square, which is nothing but 20 log 10 V naught divided by Di. And next one is the gain. So to find out the gain of the multi-stage amplifier, we are calculating that is the gain of the individual stages. So 20 log 10 AB is equal to, if you are considering the n stages means you are calculating the gain of the each stages, so that overall gain in decibel you can calculate the gain of the individual stages. So AB dB is equal to AB1 dB plus AB2 dB plus ABn dB. And the advantages of representation of gain in decibels. So here the logarithmic scale we are preferring over the linear scale for representing the power and the voltage gain, due to the reasons that is in multi-stage amplifier it only permits some of the individual, that is added individual gains of the stages for finding out the overall gain. And next one is this allows us to denote that is both very small as well as the large quantities. And also, for example, if this the voltage gain is 0.00000001, we can represent this minus 140 dB, and the voltage gain of 1 lakh can be represented as 100 dB. So if many times the output of the amplifier is fed to the loudspeakers to provide the sound, but which is received by the human ear, it is very important to note that the ear responds only to the sound intensities, but it does not respond on the rather than the linear scale. So here the use of this decibel unit is more appropriate for representation of amplifier gains. And the quiz questions on the multi-stage amplifier is radio receiver has which type of amplification, RC coupling is used for which type of amplification. In an RC coupled amplifier the voltage gain over mid frequency is what.